Hello, my name is Brock Lemires and I'm the president of Resilient Computing. I want to thank you for taking the time to take a look at our evaluation unit. We really appreciate if you'd give us as much feedback as you can, both on the hardware features that we have, in addition to the documentation and ease of software install and use. So in this video, I'm going to walk you through opening the box and getting you plugged in and making sure that everything is up and running, and talk about some of the terminology that we use. And then in subsequent videos, we're going to show you how to install the software and access the documentation. Okay, so first of all, we use a term called RadPC often. That is the name that we have come up with to describe our radiation tolerant architecture. And so what it is it's meant to be implemented on a commercial FPGA, field programmable gate array, and it consists of a series of fault mitigation strategies. So over here is kind of a very high level overview of what we do. We have redundant RISC-V CPUs, we have a voting system on the outputs, we have votings on the register, we have memory scrubbers on the data memory and the instruction memory. We have a software mitigation system. We do partial reconfiguration. So we have all of these things put together in order to provide to you an abstracted computer where you can just treat it as a traditional microcontroller and write software in C, and you don't have to worry about any of the fault recovery mechanisms that happen behind it. And this is actually a patented thing that our company has, and we call that architecture RadPC. Now it's meant to go on a commercial FPGA, and you can tell right away this is written and developed by us in RTL, meaning that we can port it to any FPGA. But we happen to put it on our first single board computer on an AMD RTX 7 200T FPGA, and then we provide this to you as a full solution. And so this right here is the single board computer that has RadPC on it, and we call this board Hydra. And so you'll see this little logo over here of the 4 heads on here. And so RadPC on this board right here, this is RadPC on the Hydra single board computer. When we bring out other offerings of this single board computer, it will have different names. But this one right here is meant to be in a stacked configuration inside of basically a CubeSat. And so that's the difference between RadPC and Hydra. RadPC is the computer architecture that runs on the FPGA. Hydra is the board that it sits on. Okay, so if you take a look at this Hydra single board computer, just kind of an overview of some of the features that you have. So first of all, this is an FPGA. It's a RTX 7 200T, but you don't actually get to use it as an FPGA. It runs the computer system, and you treat this entire board as just like any other computer that you drop software onto. Other things of interest to you, just for reference, this thing has its own onboard crystal oscillator. It's got an MSP430 microcontroller that handles housekeeping and some of our fault recovery procedures. We've got NAND flash up here to hold the FPGA configuration bit streams that you don't have to worry about. That's where RadPC lives. And when you power it up, it boots it. And then we also have non-volatile memory to hold your software so that once you load it onto here, you can take the power away and then come back, power it up, and it'll reconfigure the FPGA and also then put your software into there. This down here, we chose to go with our first offering, 120-pin PC104 interface. We are electrically compatible with the PC104 standard. We are not protocol compatible. And this is really the big difference of the Hydra board. So subsequent offerings will have different connectors here, or different interfacing, and they'll stack differently. Within the RadPC computer, you're going to have on FPGA memory that is a whopping 12K for data memory, 12K for instruction memory, but we also have 1 megabit quad redundant memory on the backside of the board that's all available for you to use in any fashion you want, that is memory mapped into the system. So you actually can access this memory on the back. So you have a lot more memory than initially what you have on the FPGA. Okay, so this is what it's going to look like once you get set up. Just some terminology. You're going to have the Hydra board right here running RadPC. Over here, you're going to have what we call the programming and power puck, and you're going to connect it through a little cable into this connector right here that we'll refer to as a PMOD. So this is kind of something from like the Raspberry Pis and other single board computers, but it's just a standard PMOD. We follow that connection scheme. You'll notice when you plug all these things in, the cables have little labels on them that'll help you orient how you plug them in. And with the puck, you have one cable that comes into RadPC, the Hydra board, and over here though, we're going to have 2 different ports. So one port is just going to be be a USB-C for power that you can plug into a computer or a wall wart. And then you're going to have a second port right here that goes to an FTDI SPI cable. And these everything is in the box, but this cable right here, this is how you actually download your software executables that then get placed into the RadPC memory or the Hydra board memory, so that when your FPGA boots up and then loads its first program, that's how you get it into the actual CPU. You're also going to get this LED shield that sits right here, and this is just going to allow you to write programs and flash, the GPIO that are all routed to this PC104 connector. So you can basically do like a blinky pattern or whatever, just to make sure that your program is on there. Now, your RadPC Hydra board is going to come loaded with a demo program. So you'll see LEDs flowing right here and lighting up in a particular pattern. But then what's going to happen is you'll be able to download and overwrite that program using your own software. Now, one thing to keep in mind is that this is an FPGA. So when you power it up for the first time, it's going to take about 30 seconds to configure the device with RadPC, and then nothing will be happening. So just because you turn it on, nothing happens, doesn't mean it isn't working. It's just configuring the FPGA. Then it will load your program, and then you'll start to see LEDs blinking. And after you get it loaded and keep the power on, you can load your software very quickly. It only takes a couple seconds, just like any other microcontroller. Okay, so at this point, what I'm going to do is hand it over to Hez, our design engineer, who is going to walk you through opening the actual box.
RadPC Hydra single board computer, unboxing and hardware setup. Product will come in a Pelican case. This is the Hydra board with the LED shield on top of it, in the SD bag. USB-C cable, second level, power puck, power and SPI cable, and then SPI to USB cable to the computer. And that is everything that's in the Pelican case. Unpackage the PCB stack. There will be 3 parts to this. You will have a mount for it to sit on, the actual Hydra computer with RadPC on it, and then an LED and hex display shield for the display. This only has foam to protect the standoffs during transport, so you can put that aside. Working out, the power and SPI cable will plug into the PMOD on the upper left-hand corner. Power will be the lowest pin, ground will be the next pin up. From there, you're going to go to the power puck. Marked, you're going to hook up I/O, ground, and VCC. Here, you will need to push fairly hard to get that in there. It's a fairly tight fit. From there, this is your connection to the computer via SPI to USB. This uses the FTDI cable. You will note all the pins that are not in use are completely covered, so you cannot plug in the wrong pin. And all of the pins that we are using are labeled on here, exactly what they are, and then the color code. So black is to the left, then orange, green, and yellow. That plugs into the top side of the board here. The other end, go to a USB on your computer. Finally, you have power. That's your USB-C cable. It's going to plug in on the left side of the puck. And then the other side needs to either go to a computer, or in this case, I'm plugging into a wall wart directly onto the wall. Then we have RadPC booting up. This will take about 30 seconds. It's doing a full configuration of the FPGA, then it's bootloading the actual RadPC architecture. And there we go. This will be one of the default patterns. As you can see, we have the LEDs counting down, and then we have RPC on the hex displays.
And that is opening the RadPC Hydra board box. So in our next video, what we're going to do is look at installing the software and accessing the documentation.